Okay, so now let's talk about the other inverse trig functions, right? And we don't really need to know too much about it, actually, which is nice. So, for example, right, let's say that I wanted to compute, right, let's call this an example, might as well. Let's suppose that I wanted to compute arccosecant of, I don't know, how about square root of 2? Now, I haven't even defined what arccosecant is, right? I haven't looked at intervals on which cosecant is 1 to 1 or anything like that, and I really don't need to know that. So here's what I'm going to do instead. To evaluate this, I'm going to let theta be equal to arccosecant of square root of 2. Okay? So then now, like supposing that we can define this arccosecant, all right, and that we've looked at the domain and everything like that. That means that using the inverse property, we would have that cosecant of theta is equal to square root of 2. But cosecant of theta is the same thing as 1 over sine of theta, right? So then 1 over sine of theta is equal to square root of 2. And then now we can solve for sine of theta by taking reciprocals on both sides. That sine of theta is equal to 1 over the square root of 2, which of course we can rationalize. So this is the same thing as having sine of theta is equal to square root of 2 over 2. And so we can find out what arccosecant of square root of 2 is by just solving this equation. Sine of theta is equal to square root of 2 over 2. So, so we look at the unit circle and we see that theta could be pi over 4 or 3 pi over 4. Right? But it can't be 3 pi over 4, right? Because that's not in the restricted domain for sine, right? And so it must be pi over 4 as your answer. Okay. And so this technique that I just used, relating arccosecant back to basically sine of theta, this is something that actually we can do for all three of the arccosecant, arcsecant, and arctangent functions. So basically, here's the rule. It's a reciprocal relationship. So arccosecant, oops, spelled that one wrong. Arccosecant of a real number r is equal to arcsine of 1 divided by r. So for instance, computing arccosecant of square root of 2 is the same thing as computing arcsine of 1 over the square root of 2, which is the same thing as arcsine of square root of 2 over 2. And that's how we got pi over 4. Same thing with arcsecant. Since secant is a reciprocal of cosine, arcsecant of a real number r will just be arccosine of 1 divided by r. And then arccotangent of r will just be equal to arctangent of 1 over r. And so, as another example here, right, let's say that I just wanted to compute, arctangent of, how about square root of 3? Okay. Well, sorry, I said arctangent, but arccotangent of square root of 3. Not enough C's in there. Try that one more time here. Arccotangent of square root of 3. Right, well, that's the same thing as arctangent of 1 divided by the square root of 3, which we can rationalize. That's just arctangent of square root of 3 over 3, right? And so we're looking for an angle where tangent of theta is equal to square root of 3 over 3, and that happens to occur at pi over 6. Okay, so arccotangent of square root of 3 is just pi over 6. So another quick example here. Let's suppose I wanted to do how about secant of 1/2? Okay, well, arcsecant of 1/2 would be the same thing as arccosine of 2, right? Take the reciprocal. But of course, arccosine of 2 is undefined, right? The domain of arccosine is -1 to +1. So arccosine of 2 is undefined. So then arcsecant of 1/2 is also undefined. Okay, so basically, anytime we have an arccosecant, arcsecant, or arccotangent, we can convert it to be arcsine arccosine or arctangent, respectively. So there's no need to really discuss those ones further.